right now? I guess not, huh? Hypotenuse over adjacent. Okay, and then guess what the last one is? Cotangent. And please don't say tan, please don't say cot, please don't say sin or cos. That's not what they are. Use the correct terminology, please. Okay, so if you come up and say, I don't understand the sin. I'm like, no, neither do I, because we're not sinning. By the way, my daughter said I'm going to go live with Satan.
Why?
I don't know what I did. It was on like 2 Sundays ago. She said, Dad, you're going to live with Satan. I'm like, oh.
How old is she?
5. She's very attuned to the spirit. Huh? COT. Cotangent. Sorry about that. And that is adjacent over opposite. Now, I just want to let you guys know we're going to use them a little bit, not too much, but enough. Does that make sense? The main 3 that you really need to know are what? Sine, cosine, and tangent. This is a section that uses your calculator, because we are going to be using calculators today. You do need a scientific calculator. I'm going to show you how to maneuver that. But not a calculator. Oh, okay. I like it even better now. Sorry about that. Everybody pulls out their dang phones and says, "Does it count?" No. Okay. So let's actually do something, okay? So if I had this lovely triangle, and I'm going to put theta up here this time. Let's say this guy is 3 and this guy is 5. Could I find all 6 of my trig functions right now if I asked you to? How? I don't have my adjacent side. How can I do all my 6 trig functions if I don't have my adjacent side? Huh? Pythagorean theorem. You guys remember that theorem? Pythagorean theorem. Good job. Okay, so remember, Pythagorean theorem tells us that this squared plus this squared equals this squared, right? Very basic theorem that you learned, okay? 3 squared plus, we'll call him x right now, squared equals 5 squared. So therefore that's 9 plus x squared equals 25. X squared equals 15, x equals 4.
Wait, is that in the corner of that thing?
Yes, this right here?
Yeah.
That is the angle, yeah. And that's called theta. Okay, so therefore, now I could stand at theta and I could say, okay, what is the cosine of theta? I could ask that. Anyone? What is cosine? The cos with the adjacent. Which one's the adjacent between it? The 4, because he's the one next to, right? And which one's the hypotenuse? Good. Okay. What if I ask you the cotangent of theta? Remember, the cotangent is the reciprocal of tangent. So therefore, if you had your SOHCAHTOA, tangent is opposite over adjacent, so therefore cotangent is adjacent over opposite. Does that make sense? So which one is my adjacent? It's the one next to. Which one's my opposite? Okay, I could ask you the sine. What's the sine? Opposite over adjacent, right? Opposite over hypotenuse, so that's 3/5. And then I could ask you the cosecant, which is just a reciprocal, correct? What is it? 5 over 2. Make sense to everyone? Anybody have a question? 5 over 2. That's the cosecant. Okay, now sometimes people forget and say, oh, I believe cosecant goes with cosine. Why would people probably think that? They both have the cos, right? Okay, so for remembering that, I I have a little saying to myself. I know it's very simple, but I say the co's don't go. Okay, so the co's don't go together. Cosine and cosecant do not go together. Cosecant goes with sine, secant goes with cosine. Okay, the only tangent, obviously cotangent and tangent, I hopefully you can understand they go together because of the word tangent. Okay, but the co's don't go. That's my reasoning, a little helpful to be aware of, that cosecant goes with sine, cosine goes with secant. If I wanted to do that one, that would be 5 and 4. Anybody have a question there? Yes, no, maybe so? Sure. Okay, so let's do another one. That's a 1. Let's make them a 1. Well, let's not do both of those right now. Make him a 1. Here's my theta. Okay, I'm going to call him alpha. Okay, so first off, what do we need to find? Anyone, huh? The other side by doing? Good old Pythagoras, right? Pythagoras is our friend when it comes to right triangle trig. Okay, yes, my lady.
I just don't know if you know the opposite of what
Okay, so let's think about the word opposite with Jason. Okay, let's try to find this side and then I'll help you with that. Right? There you go. Because I'm going to ask you cosine stuff and we'll talk about Jason too. Okay. So first off, 25 equals 1 squared plus x squared. Is everybody okay there? Everybody understand where I got the 25 from? I'm sorry. 5 squared. So this is 25 equals 1 plus x squared. Subtract the 1. 24 equals x squared. X equals 24. Underneath the square root, correct? Is that where we leave it, James? Why? What's in 24? 2 and 12. What's in 12? What's in 6? What are we looking for? Groups of 2. So there's my buddy, right? So therefore, who gets to come out? The 2 who stays under. So this side is 2 root 6. Does everybody understand that? All right. Now, coming back to your question, okay, it all depends about what we're asking. So let's first start at, let's cosine of theta and the cosine of alpha. Okay, because those are 2 different angles, correct? Okay, so let's start with the cosine of theta. Now, what is adjacent? Now, what is cosine again? It's adjacent over the hypotenuse, right? What does adjacent mean to you? Next to. Okay, so here's theta. So who is next to theta? 1 and 5, right? Those 2 are there. But what is the name of 5 already? So therefore, who's the adjacent? Does that make sense how I determine it? Okay. So therefore, cosine is adjacent over hypotenuse. Everybody there with me? Understanding? Ooh, that's a good stretch of the calf right there. I like that. Ooh, nice. Okay, so now if we go to alpha now. If I'm saying at alpha, who's my adjacent? 2 root 6 is, huh? Over 5. So it all depends about where you're standing. If I'm here, then the 2 root 6 is it, right? And notice opposite, away from, right? That'll help you determine that. Hi.
Is the angle you're trying to find is the right angle? Which one's the adjacent?
You'll never stand at the right angle. So, neither. Okay. I will show you what those are when we get to our unit circles. All right. Now, obviously, you guys all have this written down, right, at least, so that I can maybe ask you, okay, so let's do what the cosecant is of alpha. Cosecant of alpha. So remember, cosecant is the reciprocal of sine, and what is sine? Opposite over hypotenuse, so therefore, this is going to be the hypotenuse over the opposite, right? So therefore, it's going to be 5 over 1, correct? Which is this 5. We like that 5. Anybody have a question there? You guys feeling pretty comfy? Not too hard yet, right? Pretty much a review. You guys remember this from last year? Okay? And then, let's say if I said the cosecant though of theta. This one's a little bit different. So once again, it's the opposite over the hypotenuse would be sine, so therefore it's the hypotenuse over the opposite, correct? So therefore, 5 over who? 2 root 6. What's wrong with that though, guys? There's a radical in my denominator, huh? Do we like radicals in our denominator? No. So what do I need to do? I got 1 6. How many more 6's does he need? 1 more. He needs 2 total, so he needs 1 more 6, doesn't he? Then I got to do it to the top. So that's known as 5 root 6 over, we already had the 2 out there, but what's root 6 times root 6? Root 36, which is 6. And 2 times 6 is 12. So that's 5 root 6 over 12 at the time. Is everybody okay there? Understanding what we have? Is that good for you? Anybody want me to go over another triangle? Okay, so they're going to ask you those, like for, just find the cosine of theta and so forth. Okay? Now, the reason why we know this is, the reason why trig functions are important is because every angle has their very own ratio of cosines and so forth. If we actually looked in the back of your book, which I doubt any of you guys brought it, right? You guys are, you brought your book? Impressive. I'm not going to open it up. You should have. So make sure you know where that's at, because that thing's worth $100. It's a $100 bill sitting somewhere.
I never even got a book though. Like, where would it be?
It'd be in the thingamajig.
I know that's
Down the hall. It's in the book checkout area. Anyway, okay, the book depository. That's what it's called. Thank you, Michelina. Anyway, in the back in the day when they didn't have a calculator, they used to just have a chart that would tell you every angle's ratio. But that's only whole angles, right? What about 35.9? What about 35.2? What about 45.8? You know what I mean? Those weren't always in there. And so, but let's go ahead and talk about it. Every angle has its very own ratio. Okay? There's a ratio that has to be given up, okay, to make that work. So, let's go ahead and solve for x here in this situation. Now I'm going to go ahead and have x, and this guy being 75, and this guy being 32 degrees. This is where our calculator is nice and dandy, instead of looking at the chart. Uh-oh. Ah! Does it smell like pina colada? What does it smell like? Be right behind you. Why does it smell broken? Oh well. We'll look into that. Okay, so 32 degrees, right? We're standing at 32 degrees. What does the x represent in 32 degrees if I'm standing at 32? Opposite, what does the 75 represent? Sorry, I pretty even got to drop it. It is the hypotenuse. What trig function uses opposite and hypotenuse? Sine does, doesn't it? So then we have the sine of 32 equals x over 75. So as I just said, every angle has its very own ratio for sine, cosine, and tangent. Okay? So there's only specific ratios that make that work. So this is a ratio. You guys remember what ratios were? Like 2/3 is 4/6, right? Those are a ratio. Well, this ratio, whatever it might be, I don't know what it is, has to equal some number over 75, right? So if I was going to solve, how would I go ahead and get x by itself? Really simple, nothing too hard. Would you? Times by 75, because this is division, right? We times by 75. Okay, so x equals 75 sine of 32. Now we go to the machine. Go to the machine! You should have a machine, right? Somehow, some way, a machine, a scientific machine. First thing you need to do, get out of here, is to first off check your mode. Okay, you need to be in the correct mode. Notice right now, I am in radian mode. So I need to go down and I need to be in degree mode. Okay, so check your mode. If you have a dinky calculator, like, no, I'm sorry, no offense to your dinky calculator. Oh, actually yours I like, because it's a TI skill. If you have a dink, no offense to yours, Adam. Get it in the right mode, okay? And then you need to be in degree mode, like your dinky calculator. Are you in a degree mode?
No.
How do you check? Let me check. Oh, we're not recording. Darn it, we missed all the good stories. He likes to protect his nuts, and so if anybody gets close to this, he shoots them. So far he's not close enough because he hasn't got close back. Okay? Now the farthest distance away from him, okay, we don't know. We don't know what that is. But we do know that this is 100 feet away. That boulder is 100 feet away. Okay? And this squirrel is no other squirrel. He knows his angle of depression is 15 degrees. Okay? So where is that angle going to be at? Okay, so right, is it this one? No. Because remember, this is the angle of depression. That's 15 degrees. Does that make sense to everybody? Why that's the angle of depression? Okay? So 15. You go away. 15. So therefore, how much is this right here? Well, this would be a 90 degree angle, right?
Yeah.
So this is 75 right here. Does everybody understand how that's 75 if your angle of depression is 15? Okay. So, the squirrel, he got some rope. Okay? He has 150 feet of rope. So, he wants to know if he shoots his bow attached to, the arrow attached to the rope, is it going to kill this person and be able to drag him up and decompose his body? Because he's protecting his nuts. Okay?
Why does he need defense in his body?
Well, because he doesn't want evidence flying around. Just you got the idea. He's going to hang him in his tree. Okay, this killer squirrel. Okay, so he has 150 feet of rope. Okay? So obviously, when he shoots, he's wondering if he has enough feet of rope to hold on to it and carry him back up, because this is no other squirrel. Okay, once again. So does he have enough? How are we going to find that out? Well, we want to know this distance. No. Okay, which trig function am I going to use? Why is it the sine? Man, I've been using sine a lot today, haven't I? It's not always going to be sine, I apologize. What's this side represent? What's this side represent? Hypotenuse, so that is why it's sine, so I've set it up as sine of, how much? 75 degrees equals opposite over hypotenuse, which we don't know. Anybody want to help me set this equation up? Flip it, that's what I would do personally, yep. 1 over the sine of 75 equals x over 100. Good job there, Adam. And then last but not least, multiply by 100. I think that's how you say Stuart. That makes it 100 now, right? So x equals 100 over the sine of 75. I'm going to let you guys plug that into your calculator and tell me what you get. 100 and what? 103? Is that, I got a second on that? 103.52. So, this distance is 103.52. Does he have enough rope to accomplish what he wants to do? He does. Did you have a question, Lon? You want me to scroll down?